All right, so last two sections we're going to look at this week, 8.3, 8.4, are going to focus mainly on complex numbers in trig form. As I said, we'll do a little bit of stuff with complex numbers the way we already know how, but then the rest of today and tomorrow we'll focus on trig form. So remember that the way we're used to writing a complex number is just like that. Okay? That's called standard form. Standard form is when you write a real part, plus or minus, and then an imaginary part. A is the real part, B is the imaginary part. So something like 2 plus 3i. That's an example of a complex number in standard form. Any questions on that? We did that way back when we talked about like solving quadratic equations and we got imaginary answers. That's how we would usually write it. Real part, plus or minus, in this case plus, and then an imaginary part. Well, another way we can represent a complex number is to graph it. Okay, we can actually just put a dot where the complex number is. Now, we've never graphed complex numbers before, but it's very similar to graphing an xy coordinate. If you can graph the point 2, 3, then you can graph 2 plus 3i. It's the same, it's going to look exactly the same. So, the idea basically is that the real part is like the first number in the coordinate, and the imaginary part is the second number. So what's happening is we don't really call it an x and a y axis when we graph things with complex numbers. When you graph with complex numbers, it's called a complex plane. It looks like the xy plane. There's two axes, but you're not going to call them x and y. One of them is going to be the real axis. The other one is going to be the imaginary axis. So the real axis is taking the place of the x-axis. What you used to call x is now the real axis. What you used to call y, that's the imaginary axis. As far as positive and negative, it's the same directions that it would normally be. Positive is up and to the right, negatives go down and to the left. So let's just practice a few examples of graphing complex numbers. Alright, first number I want to graph is 4 minus 2i. Negative 4 minus 2i. Okay, so remember, this is your real axis. That's your imaginary. Okay. In the complex number that I just circled, what's the real part? Negative 4. And what's the imaginary part? Just negative 2. Yeah. So the real part is negative 4. The imaginary part is negative 2. So on the real axis, we're going to go to negative 4. So starting at the origin, which way is that? Left. Right? Real axis, we're going to go left 4. And then on the imaginary axis, it's a negative 2. Which way would that be? Down. Down how many?
2.
2. That's how you graph the point negative 4 minus 2i. Now what's kind of important about that is eventually we're going to have to know what quadrant a complex number is in. That's how you can figure it out. You graph it. 1, 2, 3. That's in quadrant 3. You don't have to identify the quadrant this time, but later today we will. All right, negative 2 plus 3i. Jake, what's the real part there?
The real part, the negative 2.
The negative 2. Yep. And Alec, what's the imaginary part?
The 3i.
So the imaginary part is just the
Just the second portion.
Just this, what part of that though? Because there's a number and there's a letter. We just want to focus on
Just the number.
just the number. So the imaginary part is 3. So real part -2, imaginary part 3. So Isabel, what would I do for a -2 on the real axis? Which way would I go? Left, 2. And what about for 3 on the imaginary? Go up. Left 2, up 3, and there's your point, which is in quadrant 2. Questions on that? Okay, how about 5i? What's the real part there? 0. So we're not going to go left and right at all. So you can think of it as like 0 plus 5i. And Megan, what's the imaginary part? 5. So we're going to end up going which way? Up. How many? 5. Yep. 1, 2, 3, 4, 5. There's 5i. And 6. What's the real part of 6? 6. Imaginary part? 0. So real part of 6 means just go 6 to the right. 2, 3, 4, 5, 6. If you want to think of it as 6 plus 0i, you can, but we usually just write 6. Okay. Yes?
When figuring out what quadrant it's in, if it's on the axis, are we going to say both quadrants?
It's on an axis then. To be in a quadrant, it cannot be on an axis. So that's kind of a special case. Okay. Any other questions on that? All right, so next thing we're going to look at is measuring that distance. So what I just did is I drew a line from that dot. And where did I draw it to?
The origin.
To the origin. Right? What is that called if you measure the distance from something to 0? There's a name for that.
Oh, absolute value.
It's called the absolute value. So in 1D, when you have a number line like this, put your number line. And if you wanted to know the absolute value of a number, you just look at where your number is, and you just measure how far away it is. 1, 2, 3, 4, 5. Right? Well, you're measuring the distance from 0. Well, in 2D, that's 0. It's called the origin. So if you measure the distance from the origin, that's 0. But how do you think you could figure that out? How would you get the length of that line segment? Yeah?
Make it a right triangle.
Make it a right triangle.
Whoa, whoa, whoa.
Like that?
No.
No. No, okay.
Sure.
Use the real axis.
Okay.
Go to the left 4 units.
So yeah, on the real axis, we've got that. Yep.
And go down from that line 2 units.
And then go down 2. There's our right triangle. And now we could use
The numbers. The 4 units.
And what would you do with those numbers?
Pythagorean theorem.
Use the Pythagorean theorem. So to find the absolute value of a complex number, which I'm going to write on the next page, it's really just take the real part and square it, take the imaginary part and square it, add them up and take the square root. It's just the Pythagorean theorem. So absolute value of a complex number, I already said it. Distance from the origin, real part squared, plus imaginary part squared, and then take the square root. Okay. And that's how you find the absolute value of a complex number. Just like you would with regular numbers. It's the distance from 0. Or in this case, it's the distance from the origin. Now, this is also going to be important. When you start writing complex numbers in trig form, this is one of the calculations you have to do. In fact, this calculation is going to have something to do with something like this. So that hypotenuse in that triangle, by drawing that circle, I just made the hypotenuse the what of that circle? The radius. Right? So when we talk about finding a radius for a complex number, all you're really doing is finding the absolute value of it. It's the distance from that point to the origin, which is like a radius. We're not calling it a radius yet, but we're going to coming up. So let's try this one. So the formula, I think it's simple enough. You really don't need to make a sketch. You pretty much could just plug into the formula. So if I wanted to plug in, what would I write down for this one? Okay.
3 plus 4i equals the square root of 9 plus 16.
Oh, are you writing the original problem again? Is that? Oh, okay, yeah. So we've kind of got that part. So the absolute value of 3 plus 4i equals, and then the square root of 3 squared, 9, 4 squared, 16, which in this case is the square root of 25, or what? 5. So that absolute value comes out to 5. Now, if you've got an absolute value, let's say you did something and you got this. You did all the arithmetic out and you got the square root of 20. Remember, you would have to reduce that like this. 2 square roots of 5. That doesn't apply to this problem because we didn't have one to reduce. But any questions on how to reduce a square root if that comes up? Just make sure you do that. All right. So those are the only two things that we're going to look at in standard form. Now we're going to look at doing some stuff in trig form, but some of the calculations you need to know, we just did. In fact, the absolute value one is one of them to get this done right here. Yeah.
So like what would we write for our answer to that? Would it be like I equals 5 or like what would it?
The answer, just what I circled,
Just
5.
equals 5. Okay, just 5.
Because remember, absolute value is a distance. So distance is just a number. Not an imaginary number, a real positive number. All right, so we're going to take a look at how we can write a complex number in trig form. Now, I switched to letting the real and imaginary part be represented by x and y because the real axis, which is this part, is x, and the imaginary axis, which is the second part, is always y. I figure if I use x and y, it might help you remember which one is which. Now, normally I know I put the I after, like 2 plus 3i. This is like I3. It's the same thing, right? It's just the formula we're going to come up with has the I in front, but it doesn't really matter where you put it. Okay, so that's the kind of numbers we've been working with so far. So if we want to write something in trig form, we have to get rid of the x and the y. X and y is standard form. We're going to replace the x and the y with something. Two things. First thing is we want to think of that distance from here to the origin. I'm going to think of that as the radius of a circle. So we have to find the distance from this point to the origin, which is what we just did. That's the absolute value. Okay, so that's one thing you have to find. You got to find r. The other thing you have to find is an angle. That's how polar works. It's based off of r and then an angle theta. Theta is always the angle between the x-axis and the hypotenuse. Okay. If your point was over in this quadrant, well, r would be right there, and theta would be the angle between the x-axis all the way to the dotted line. So in that case, the angle would be more than 90. Might be like 110 or something. But it's from the x-axis to the dotted line. Any question on that? All right. So let's see if we can come up with a way to get rid of the x and the y and replace it with an r and a theta. Okay. Let's start with the cosine of theta. What's cosine? What over what? Adjacent over hypotenuse. What side is adjacent to theta? X, yes. And what side is the hypotenuse?
R.
R, yep. And now my goal here is to get x by itself. So how would you put the r on the other side? Yeah.
R cosine theta.
R cosine theta. R cosine theta. So now we've got a new formula for x, and the formula is r cosine theta. In a minute, not yet, we're going to plug that in right there. That's going to be our formula we change x to. Now we have to do the same thing for y. Yep. Okay. Let's look at the sine of theta. What's the definition? What's sine?
Opposite over hypotenuse.
Opposite over hypotenuse. Here's theta. What side is opposite theta? Y. Over hypotenuse is r. Okay. Same thing. I want to get y by itself again. R sine theta. So using right triangle trig, we just came up with a formula for x and a formula for y. Now this one is going to get plugged in right there. Any questions on how we got the formulas in those two boxes? Okay. Now fill them in and write down what you have. So instead of x plus iy, change x to r cosine theta and change y to r sine theta. Leave the I right where it is. The I doesn't change at all. Now, if you look at both of those terms, r cosine theta plus ir sine theta, what do they both have in common in front of the trig function? R. And when two things have the same thing in common, what can you do? It begins with an F. You can factor it out. So instead of writing the R twice, we can just put it in front of everything once. So if you were to distribute that out, you'd have R times cosine theta plus I times R sine theta. And that is the trig form of a complex number. R cosine theta plus I sine theta. So a final answer to a problem in trig form could look like this. Let's say you had a radius of 5 and the angle was 15 degrees. Radius of 5, angle of 15. I just made those two numbers up. That's what a final answer looks like in trig form. You don't do anything with it. You don't take the cosine of 15 or distribute the 5. If you want to leave your answer in trig form, that's exactly how it'll look. So there's two things you have to figure out. R, and we've already talked about how to do it. That's the absolute value of the complex number. So we did that one. And then you have to find theta, which is the same thing here too. So R and theta. Right, so to use that form, I just said that. You need R and theta. And just a reminder of what those are if you don't remember. R is the distance from the origin. Or if you want to put in parentheses, the absolute value. That's what it really is. And theta is the angle with the positive x-axis. All right. So what theorem did we use to find R? This part we've already done. Yep. We did the Pythagorean theorem, yes. So r you should already be able to find using Pythagorean theorem. Let's look at theta. Is anyone still copying that? So let's say you've got a complex point. You graph it. It ends up in quadrant 1. It doesn't matter what quadrant it ends up in. Okay, the idea is going to be the same. Make a triangle out of that. Now, the bottom side of that triangle is how long? Okay, it's not a number. It's x. You went to the right x units. And the height of that triangle is how much? Y. And now use Pythagorean theorem to get r. We're not looking at that part. I want to look at how to get this angle. What's the name of that side that I just circled? Is it opposite, adjacent, or hypotenuse? It's opposite. What's this other side that I just circled? That's adjacent. What trig function has opposite and adjacent in it? What is it? Tangent, yes. So, tangent is opposite over adjacent. So the tangent of your angle would equal y over x. But you don't want to know the tangent of your angle. You want to know your angle. That's what you need. So we have to get rid of tangent. How do you get rid of the tangent function? Yes, take the inverse tangent of what's on the left and on the right. So theta equals the inverse tangent of y over x, and I'm going to write that out nice on the next page. Okay. Now, the only problem with inverse tangent, bless you, is inverse tangent will only give you an answer from negative 90 degrees to positive 90 degrees. In terms of my quadrants, what quadrants does that cover? 1 and 2, that would be 0 to 180.
What did you say?
Inverse tangent only gives you an answer between negative 90 and positive 90. What is it? 4 and 1, yes. Negative 90 is down here. Positive 90 is up here. So inverse tangent only gives you an answer on that right half. Well, it's kind of a problem because you could have a coordinate on the left half. Definitely can have coordinates in quadrants 2 and 3. So we'll talk about what you have to do in 2 and 3, but you got to make a small adjustment. Okay? So find r, that's pretty easy. No matter what quadrant you're in, just use Pythagorean theorem. Now, to find theta, if you're in quadrants 1 or 4, the two that we just mentioned, all you have to do is inverse tangent of y over x. It's the formula we just came up with. It works perfect. But if you're in quadrants 2 and 3, you have to make a small adjustment to that. You still have to use inverse tangent of y over x, but you have to add 180 or pi to it. So later on, I had said it's going to be important to know what quadrant your complex number is in. This is why. Because if you want to convert it to trig form, the formula that you use for the angle depends on the quadrant you're in. Quadrants 1 and 4, just the straight inverse tangent y over x. Quadrants 2 and 3, it's 180 plus inverse tangent y over x. Or if you're doing radians, pi. Now, Jake kind of touched on this earlier, but quadrants 1, 2, 3, and 4, that doesn't cover everywhere that a point could be. Where else can a point be besides in a quadrant?
On an axis or on the origin?
Well, it's always going to be,
Will it be on both?
yeah, it's always going to be on one axis or the other. It'll never be on both at the same time. So it'll never be at the origin. because then we wouldn't be able to do the problem. Because if you had a point right at the origin, then you end up with a radius of 0, and then it wipes everything out. So you won't have it right at the origin. Now, if you're here, what would your angle be?
180.
180 would be over here.
0, sorry.
0. How about if you're up here? 90. Over here is 180, and down here, 270. So if you're on an axis, you just have to remember those 4 numbers we just did. 0, 90, 180, 270. I have them right there in radians. Those are the easy ones. Okay? You don't have to use inverse tangent. You don't have to do anything like that. If you're right, it's 0. Up, 90. Left, 180. Down, 270. If you're not one of those, then you got to use the formulas I have up above. Okay? So that's how you find theta. So next we'll practice just changing a couple points from standard form to trig form. Okay. Let's try this one. So it says basically convert that to trig form. Find the trig form. So right now we've got an x and a y. What are the 2 letters you need to find in trig form? What are the 2 letters you have to get to use the trig form? R and theta, yes. So we have to calculate those 2 things. And when we're done, our answer is going to look like this. We're going to put R in that box, cosine. We're going to put theta in that box, plus I sine theta. That's exactly what your final answer is going to be. Just fill in the boxes. Find R, find theta. Okay, let's start with R. Okay, I'm going to graph it. How would I graph -2 plus 2i? Starting from the origin, which way and how many units? Yep.
-2 on the real axis, you count back 2.
Okay, so which way is it?
Left.
Left 2, yep. And then
Up 2.
up 2. Left 2, up 2, it's basically going to be right about there. That's what I want to find. Find the hypotenuse of that triangle. Left 2, up 2. So when I do Pythagorean theorem on that, what's 2 squared? 4. -2 squared? 4. Add them up and take the square root. So that's the square root of 8. Or what would that reduce to as an exact answer? Yep.
2 square roots of 2.
2 square roots of 2, yes. There's your radius. That's what's going to go in this first box. 2 root 2. R, and I normally don't put boxes around it. I'm just doing that to kind of show you. In fact, I can get rid of it.
Can we do it in degrees?
We haven't made that choice yet. We haven't gotten to the angle, but it depends on the question. So I'll do this one in degrees, but if the problem asks for radians, then you'd have to do radians.
Is R always going to be, like, say you saw it like that, does it always have to have a square root, or can you get it to a decimal?
A lot of time they're going to ask you to leave it exact, but if they do ask for a decimal, then you just type it in. So unless they ask for a decimal, I'm not going to take that extra step and do that. I'll just leave it like that. So I don't even need a calculator to figure that out. Just leave it. All right, now the angle. So the angle depends on the quadrant. Which quadrant is -2 plus 2i in? It's in quadrant 2. In quadrant 2, I have to add 180. So 180 plus inverse tangent of y over x. Right, let's do that down here. 180 plus inverse tangent. what's y? 2, and x? Negative 2. So really, that's just the inverse tangent of what? Negative 1. So when I type it in, I'm just going to do it that way. 180 plus inverse tangent of negative 1 gives me an angle of 135 degrees. So now just fill that in your formula. So the final answer is going to be 2 root 2 cosine 135 plus I sine 135. And you leave it just like that. You don't do anything else to it. If you did something to it, like let's say you said, you know what, I'm going to take the cosine of 135 and I'm going to distribute the number that's on the outside of parentheses. Watch what happens. 2 square root of 2 times cosine 135. Cosine 135. You get negative 2. That's what you started with. So if you distribute it out, you're changing it back again. Okay? If I did 2 root 2 times sine 135, watch what I get there. 2 square root of 2 sine 135. I get 2 with an I next to it. 2i. 2i. So if you distribute it out, I guess that's a good way you could check your answer, but you don't want to do anything and actually write it down. Leave it just like this. Okay? Distributing it back out changes your answer back to what you started with. There'll be some problems where they want us to distribute it out, but not this one. We don't want to go back to what we started with. We want to stop right there. Yeah.
Maybe dumb question. If theta is 135 and you have an angle that's 90 because it's a right triangle, that's already 225 over 180.
So the 135 is right there.
Oh, okay.
It's the angle from the positive x-axis to the hypotenuse. Yeah, that's not actually an angle inside the triangle, it's outside the triangle.
Okay.
Okay. Any questions on that one? All right, let's try. All right, so that's how you write numbers in trig form. We have another one we'll practice as we're doing a problem. So the reason why we write numbers in trig form, that's what we're going to spend the rest of today and tomorrow on. It gives us a fast way to do 4 different things. Multiply, divide, those are pretty straightforward. Raise to a power, which we'll see tomorrow, that's pretty straightforward. And then the opposite of a power is a root. That's a little harder. Now, I'm going to review very quickly how you would have to divide these complex numbers if we were doing it the old way. Okay. The old way, I would have a problem like this. Now, in order to do this out, I would have to multiply top and bottom by, does anyone remember? It begins with a C. The conjugate. The conjugate of 5 plus I is 5 minus I. So that's the first thing. You got to remember to multiply by the conjugate. And now you have to FOIL it all out. And this one's not even that bad because the top is just a real number. If the top was like 3 plus 2i, I would have to do FOIL. This is really just distributive. So 15 minus 3i. And now in the bottom, you have to FOIL it all out. So 5 times 5 is 25. 5 times negative I. 5 times positive I. And now the last part, positive times negative. What's a positive times a negative? A negative. What's I times I? Well, before we get there, let's just write I times I. Just I squared. But now you have to remember something else. You got to remember that I squared is negative 1. So in the top, you've got 15 minus 3i. Now, negative 5i plus 5i, those really just cancel out. And in the bottom, I have 25 minus I squared. That's 25 minus minus 1, which becomes what? Becomes plus 1, which is really 26. So the final answer, your real part is 15 over 26, and your imaginary part is negative 3 over 26. I just took each number in the top and put them over 26 separately. And that's how you would have to do division the old way. A lot of different things to remember. Foiling, I squared, the conjugates, combined-like terms, things that cancel, all that stuff. Well, if we use trig form, all of that goes away. You don't have to do any of that stuff. Right, so I'm going to show you how to multiply and divide two numbers in trig form. Now, this method really only saves you time if what you're trying to multiply or divide already is in trig form. If it's in standard form, it's probably going to be quicker to just do it that way. But if they give you something in trig form, this way is going to be a lot faster. So we have two complex numbers, z1 and z2. Each complex number has its own radius and its own angle. So when we do an actual problem, just to show you, I'll give you one, give you the radius, and I'll give you an angle. They'll all be numbers. So, first formula I'm going to look at is multiplying. To multiply these two complex numbers together, you're not going to have to do any foiling or I squared. You have to do two things. The first thing is multiply your two radii together. Take the first radius, multiply it by the second radius, and that's half of it. Okay. The second thing you have to do is take the two angles that you were given and add them up. And that's it. Multiply the two radii, add the two angles. And that takes the place of all the stuff we just did. It's a much easier calculation. But the trick is your numbers have to already be in trig form. Now, how about dividing two complex numbers? I just reviewed this with you the old way. What do you think you would do to do it the new way? What do you think you would do with R1 and R2? You would divide them. Yep. And you'd subtract your angles. Yes. And of course, R2 couldn't be 0 because then you'd be dividing by 0 and you can never divide by 0. Right? So to divide two complex numbers in trig form, two things. Divide your radii, subtract your angles. And yes, the order is important. Whichever one is on top, subtract that first. Whichever one is on the bottom, you're going to subtract that second.
So if R2 equals 0, does that mean there's no solution?
Yeah, that would be like what Nate said. Your point is at the origin. And I said you'll never have one where the radius is 0. Yeah. It would mean that, but I won't give you one like that. Okay. Any questions on the two formulas? Okay, let's try we'll try an example. Now, let's see. We'll do this part together. This bottom one you already did. And if you're looking like, I don't remember that. Well, look at this. Negative 2 plus 2i. Negative 2 plus 2i. That's the exact problem we already did. The radius was 2 root 2. There's the radius, 2 root 2. Now, I didn't put 135, I put 2.36. Well, if you take 135 and multiply by pi and divide by 180. What did I just do? I just changed it to radians, and it's 2.36. So that is 135 in radians, 2.36. Okay. Let's practice finding the radius and the angle together on this one. It's nice when you have a 3 and a 4 because you're looking at a triangle like this. 3, 4. What's the radius going to be? 5 if you use the Pythagorean theorem. That's 5. Now, what quadrant is that point in? 1. What's the formula to find theta if you're in quadrant 1?
Inverse tangent, whatever.
Inverse tangent y over x. And if you saw, I had 0.93. I think that's what was written down. That well, that's 53.13 in degrees. But we're practicing radians. Let me type it in radians. That's where the 0.93 came from. Okay. Inverse tangent of y over x. Okay, and since we got some decimals on this one, we'll round everything to decimals in the final answer. Two decimal places. Okay, so they want us to multiply these together and divide them.
Is the top one radians as well?
Everything is radians, yes. Yep. If it was degrees, you would know it's degrees because you'd see the circle on it. Remember, if there's no circle, it's radians. All right. To multiply these together, what do I do with my 2 radii? Multiply them. 5 times 2, square root of 2. That's about 14.14. So that's my radius. Now, when I'm multiplying these together, what do I do to get my angle?
Add the angles together.
Add the angles together. 0.93 plus 2.36. And there's your angle, 3.29. And what we just did takes the place of all that foiling, all the I-squared stuff. You don't have to do any of it. But what sped this up is we already did one of these problems and had the trig form. Z2 we already had. Right. Now I want to divide these numbers.
So that's the final answer.
That's the final answer. Yep. If they say leave the answer in trig form, which they did here, in trig form, you stop there. If they said standard form, the last thing you would do is distribute that out and use your calculator. 14.14 times cosine 3.29, write it down. 14.14 times sine 3.29, and then write that down. But they did not say standard form. Now I want to divide them. So what am I going to do with my radii? I'm going to divide them. 5 divided by 2 square root 2. Just like that. So my radius is 1.77. So that's our radius. And what do I do to get my angle? Subtract 0.93 minus 2.36. I just typed it in wrong. 0.93 minus 2.36. Okay, so we get an angle of negative 1.43. So we get cosine negative 1.43 plus I sine negative 1.43. Now, technically, they didn't say anything about getting rid of a negative angle. So that answer is fine. If it's matching up, and they match it, you might see answers that only have positive angles. So there's 2 ways if you have to get rid of a negative in front of an angle to do it. The first way involves something you can add to that number. If it was degrees, you could add 360.
2 pi.
Or in radians, we could add 2 pi. That's one way to change it from a negative angle to a positive. 4.85. 4.85 plus I sine 4.85. Both of those answers are correct. The second way, you can get rid of a negative. Let me take the cosine of negative 1.43. Negative 1.43. And we get that. Let's take the cosine of positive 1.43. What's the difference? Nothing. So when you have a negative with a cosine, the negative actually it doesn't even matter. You can just get rid of it. It doesn't make a difference. Negative 1.43, positive 1.43, if you're dealing with cosine, it's the same thing. Now, let's look at the same thing for sine. Sine, negative 1.43, sine 1.43. Are those the same?
No.
They're not the same. But what are they?
Reverse.
They're opposites, right? So the sine of negative 1.43 is the same as the negative sine of 1.43. So you can't just get rid of the negative, but what you can do is put it in front. Okay? Does everyone see how having the negative on the inside and then moving it to the front, the answers come out the same? Doesn't matter which sign, if you get the negative on the inside or you put it in front. So if they ask you to get rid of it, you can just put it in the front and this would turn into a minus. I sine 1.43. All of those answers are correct. Only time you really have to worry about that if it's multiple choice and you get an answer like this and you don't see it listed. Maybe you would see the second one listed or the third one, but they're all correct. So out of the 4 operations we're going to study, multiply, divide, powers, and roots, I'll probably pick 3 of them to put on the test. Just because they can kind of take a long time, and so can law of sines and law of cosines. So I'll pick 3 out of 4 for the test. Any questions on the multiply and the divide operations? Okay, so those are the first 2. Tomorrow we'll look at the last 2. Okay, so homework tonight, page 450. And it's 1 through 3, 5, 8, 11 through 14, 17 through 20, 33, 34, and 37. So we'll look at that tomorrow. Reminder, I'm after school tomorrow. If you need to make up a test from last week and you've got to do it after school, tomorrow's the only day to do it. If you can come during the day, that's fine too.